morning, everyone, and welcome to today's webinar, Preparing for the Internet Zombie Apocalypse, Best Practices for Securing Your Website. Your speaker for today is Josh Koenig, co-founder and head of developer experience here at Pantheon. Just a few housekeeping items to go over before we start. Please make sure you submit any questions you have during the presentation in the question window or tweet them to @GetPantheon. We will answer as many questions as we can during the Q&A portion of today's presentation. Also, this webinar will be recorded, and the recording will be made available to everyone next week. I'd now like to turn it over to Josh.
Thanks, Atusa. Thank you all for joining us today, and we're just going to go ahead and jump right in. So, websites are not safe. It's kind of an obvious thing to state, but websites are high-profile targets for data theft, defacement, and other criminal activity. In fact, in 2014, the last year for which statistics are available, according to the FBI, 35% of all major data breaches came from websites. That includes a number of different ways in which websites are compromised. They can be compromised by data being taken directly out of the website. Oftentimes, while you may not be storing credit card data in your website, there's other sensitive or personally identifiable information there that can be used. And websites are also used as a beachhead for further incursions into an infrastructure. So while your website itself might not handle the most sensitive data, if the website is adjacent to something very sensitive, it can then be used as a point of attack. So your website is compromised, and then it's used to further some nefarious operation. Websites do get hacked. This is the reality of the industry. Websites are public-facing, so they have to be accessible to the public internet on some level. That makes them both a vulnerable target and an attractive target. If you think about the range of people who could come after your website, at the very, very high end, you could have espionage agencies from foreign governments who might be going after you. They're more likely to look at your website as a way of working their way back into some more sensitive infrastructure. But you also have every 13-year-old with a vandalism urge who might just want to be able to put their name on your website, similar to how they might try to scroll graffiti across a storefront window. And so websites face a lot of hostility on the internet. And the most critical thing to realize is that whether or not you think you're a high-profile target and whether or not your website has any valuable information in it, and whether or not it's associated with a critical internal system or not, it is actually being attacked right now as this webinar is occurring. This is the Internet Zombie Apocalypse, the title of the webinar. The average web server faces over 8,000 dictionary attacks a day. That's one of a series of classification attacks that are constantly being made on all infrastructure on the internet at all times by what I call the zombie horde. Over the past decade, a lot of amazing stuff has happened with cloud systems and virtualization that makes it easier than ever to set up infrastructure, to run a website, or to run a mail server, or to run whatever infrastructure you'd like. You can get a droplet, you can get an EC2 instance, you can spin up a VM, you can provision new infrastructure very easily. And this is great. It's enabled us to have a flourishing boom of productivity, a lot of new projects coming to being, a lot of costs going down, a lot of things being made easier and quicker, but there's not enough system administration talent in the world to keep up with all this infrastructure that's being created through all these easy-to-use services. And as infrastructure is put online and not maintained, it eventually falls victim to the zombie horde. Basically, the way this works is people use compromised systems to compromise other systems, and it really is this thing that just grows and grows over time. You have if you have 1,000 servers or 1,000 vulnerable Windows desktops under your control as a black hat, as a hacker, you can use those 1,000 systems to automatically run attempts to compromise other systems just blindly at random. It really is like a shambling zombie that's just going along, kind of like trying to take down whatever it can get its hands on. And it may not come across something all the time, but if you have 1,000 systems just randomly going out and attacking things, eventually they'll find another unmaintained vulnerable system, and then it's 1,001, and now the horde can grow that much faster. The internet really is kind of a hostile environment. It's no longer this kind of computing club of DARPA and high-end research institutions. It's I don't mean hostile in the sense that it's malevolent or that the internet has like evil intent. I mean hostile in the way that a harsh environment is hostile. You won't survive on the internet without protection. So The major attack vectors that you need to worry about for your website they really break down into two broad categories. You have people and you have technology. And usually when you get on a webinar like this and you have someone who's from a technology company talking to you about security, they'll talk to you a lot about the technical attack vectors, and we'll definitely get to those. But I'd like to start by talking about the people vector, because that's actually one of the most common vectors for a compromise, and it's also the one that you can't get rid of. People are going to be involved in your projects no matter what you do. You can't get rid of technology either, but you really can't cancel out the people problem. And so it's important to understand where and how the people problem can lead to vulnerability for you. And then we'll get to talk about technology as well, of course. So the thing with people is that they make mistakes, and nobody's perfect, and we all recognize that, and it's just part of being a human being. You're gonna make errors. So people make mistakes, and administrative systems often get overloaded, they become chaotic, they become messy. And in the combination of people making mistakes, and mistakes can range from accidentally giving too much information over the phone to someone who sounds like a reasonable person, like, I'm your insurance claims adjuster, tell me your social security number, and now your identity's been stolen, to choosing weak passwords, to leaving passwords in the clear, to not communicating over HTTPS. People will make all these kinds of security mistakes. And likewise, when you have administrative systems that are overmatched, and I'm not talking about system administration systems like DevOps. I'm really just talking about the things that keep track of who has access to what and try to keep those things under control and sane. When those are overmatched, what you end up with is people who have more access than they should because it was the quick way to get around some problem. Oh, just make them an admin and they'll be able to do what they need to do today. 6 months later, it turns out that those admin privileges can be used in a way that are exploitable, and that person also chose password 1 as their password. That's incredibly common, right? And oftentimes when you have these serious security breaches at what would seem to you to be major organizations that should have had a lot of safeguards in place, it's not like there was one amazing math algorithm that just cracked the system and brought it all down. It's usually more like a series of little mistakes that added up to a big breach. And the people problem is usually one or many of those mistakes. And the lack of administrative oversight is usually a compounding factor for those mistakes. So people will take advantage of the chaos of administration, find ways to impersonate users. People will take advantage of disorganization within the system. Someone who's left the company and still has access, that's a common thing, a disgruntled ex-employee. Things like that are really frequent sources of security headaches for organizations. Solving the people problem is really about controlling access without killing your productivity and minimizing the administrative chaos. So you need some way to have role-based permissions. I mean, for any sysadmins in the world right now, if you've seen laptops out there with a sticker "sudo don't" on them, right? Don't do everything as root. Don't sudo everything. It's fun to say sudo make me a sandwich, but actually you should have role-based permissions and not be going to super user powers to do everything, because that means you're basing day-to-day operations on super user capabilities. If you're a website builder, usually the first user in your CMS has these kind of all-seeing administrative powers. If you're relying on that to get your work done, then you're essentially saying we're relying on something that, if compromised, could be devastating for our day-to-day operations. So you want to create roles. You don't want to go overboard and try to model your entire organizational structure into 50 different roles, because that's going to create an impediment to getting anything done. But you want to be able to create role-based permissions and keep track of them. Keeping track of them really means having some kind of centralized account management. In the web development world, far too often it's oh yeah, some guy stuck some keys on a server somewhere, and now I have shell and I can sudo, and that's not being really audited or kept track of anywhere. Anytime you have the random spreadsheet passwords, that's a problem, because that spreadsheet gets out of date quickly. It also gets emailed around. It's very easy for it to fall into the wrong hands. If you create a centralized accounting system, which most big organizations have at least some semblance of, the challenge is they don't use it for everything, then you have a central way to see, okay, who's in and who's out, who's an employee and who's not, and what role do they have. And then you can say, hey, now that we have a centralized account management system, let's do something like have two-factor authentication on that. And two-factor authentication is where you have a second mechanism for verifying that a user attempting to log in is who they say they are. So typically it's something you might install on your phone, a little app, or a fob that you plug in. And basically what it's saying is the chance that a random actor on the internet knows the username and the password of a person is much, much higher. Like that's way more likely to be compromised than having the username, the password, and a physical device that's usually in this person's possession. You've just taken like the exploitable scenarios from somebody guessed a password or found it, or they used the same password on multiple websites, and one of those websites was the Puppy Forum, and the Puppy Forum got hacked, and now everyone who has a login on the Puppy Forum is losing access to all their systems to they got into my account on the Puppy Forum, and they also stole my phone from the coffee shop, right? It's just so much less likely to be exploited in that kind of, widespread, indiscriminate manner that a lot of security breaches begin with. You'd have to really be targeted or incredibly unlucky for something like that to go down. And you'd be much more likely to know that something happened if someone stole your phone, right? If someone steals your phone, you can say, halt the presses, reset all my passwords, do all that business, versus you might not know otherwise. And this also gets back to like people who go even further where, if you have a VPN for your company or the like, you can restrict access to the network through a central authentication system, and that allows you to create a nice safe haven in which all of your things can operate. There's a lot of cost involved in doing that too, but that's why big companies go to the trouble to set all that up. We'll get into a little bit later some of the gotchas that come with VPN access, but for now, it's still a great thing if you're thinking about administrative control. So let's talk about the technology problem. So your website is getting attacked right now, as we pointed out. When you are breached, it's important when you're thinking about security to, professionals don't fall into this fallacy that they're going to be invulnerable. Professionals recognize the fact that some sort of breach at some point is inevitable. And what's important, in addition to minimizing the chance that happens, is also minimizing the damage that will occur when it does happen. So being prepared for a breach, being prepared with what security professionals call defense in depth, meaning compromising one system doesn't necessarily give you the keys to the kingdom, and also being prepared to respond, at least quarterly or something, reviewing what are the likely things to happen, how would we respond to these scenarios, let's rate the risk of the various things that could occur, what can we do to mitigate those risks. Solving the technology problem is in part about recognizing the fact that you're going to have to respond to something and being prepared to do so. So let's talk about the typical technology problem when it comes to websites, though, which really begins with the infrastructure. So if you have a website that's running inside your internal data center, e.g. behind the firewall, or if you run a website on a single instance server that also contains other critical business systems, you are cruising for a bruisin', as my mom liked to say. This has actually been the source of a number of high-profile breaches. Here's how it goes down. You've got a website, and it's adjacent to something much more critical. Let's say the mail spool. Like all your internal company mail is sitting on a disk that is accessible or adjacent to the website software itself. The website software is compromised, not by a 14-year-old who wants to deface things and get their kicks on Twitter, but by someone with a little bit more sophistication who wants to, say, make some money. And as a result of the website being compromised, they figure out a way to get the website to read those files. Now what's occurred is the website reads the mail spool off of that disk, sends it to the attacker, and now your dirty laundry is being aired in public, or the threat of that dirty laundry being aired in public is being held for ransom over your head. This has happened countless times, and it's one of the most common mistakes. You don't want your website, which is an inevitable target, to be sitting next to something much more critical. And this actually still happens on the VPN model in an alarming number of cases where because the website wants to integrate with some core business system because that's what makes the website valuable. I'm not saying don't integrate your website with stuff because that's how really great website experiences start. But because the website wants to integrate, the answer is, we'll just create a VPN connection. And what that does is it's good in that it protects the internal system from being publicly accessible on the internet. That's good. It protects the communications between the website and the internal system because they're on an encrypted channel. That's good. But it means that if the website is ever compromised, that VPN is kind of like an open highway into everything on the network. And so you're potentially setting up a lot of other compromises to occur unless that there's additional layers of access placed on that. By default, usually when you add something to the VPN, it's just like it's on the network. It's kind of an open channel. It can try to do whatever it can try to do. And that can be basically similar to having it behind the firewall. Same set of problems there. And when you go to that kind of virtualization, you also are confronting the root cause of the zombie horde problem, which is that when an organization embraces virtualization because of all the operational agility and everything else you can do from a velocity standpoint, you're just creating a lot of system administrative overhead that may or may not be factored into the cost of getting things set up. Again, there's just not enough sysadmin talent in the world to manually look after all the systems that are being created. System administration classically is this kind of artisanal craft where people spend hours figuring out how to architect the one system. They name their servers clever things, and they have a kind of a deep relationship with the systems that they administer. The scale at which we're now deploying infrastructure on the internet, it just can't be dealt with that way. This is why people will say, treat your servers like cattle, not like pets. It's a good metaphor for the model that the future needs. We can't really be looking after our systems on a one-off way if we want things to scale. There's just not enough people to do it. And likewise, if you're going through virtualization, you're still managing the full stack. You're still responsible for everything, and you can have these noisy neighbor issues. That's a common thing from a performance standpoint, but it's also a security attack vector. These times when the cloud providers will have to do like massive rolling reboots across their entire infrastructures, something we've dealt with in the past at Pantheon. Those rolling reboots are in response to a core security vulnerability at the hypervisor level, which is really scary because if you have other tenants on your core system, you don't even know who those people are. They could be working through the hypervisor to compromise your stuff, which you probably don't want. So solving the hosting problem, we're big believers in this the containerization model, which is about creating a limited environment. So the container model is just, it's kind of like virtualization, but it has some benefits from an agility standpoint. And more importantly, from the way that we look at it for web infrastructure, it's about creating a very limited environment. The container isn't a virtual machine where anything can be done. It's really a kind of a containerized, it's a contained system. That's what they call it that. That's really, in our case, geared towards running the website. And we think that's a great model for doing this. If you don't want to go full containers, you can still get a lot of value out of virtualization. You just need to have automated everything in your virtualization process. And we'll talk a little bit more about systems automation later, and there's a lot of cool tools that are coming up to help people do that. The point is that you want to have individual containers, whether that's a quote-unquote Linux container like we use or a virtual machine, around every single one of your properties so that like your corporate site and your community site also aren't, contagion attack vectors for each other. And if they have access to internal systems and data, you want that access to be pinpoint targeted. You don't want to have an open channel like a VPN. You want to have a specific service that's exposed to a specific external property over the secure and encrypted channel, so that you know that what is actually being exposed, the attack surface is very limited, and if there's ever a need, you can shut it down very quickly and know exactly how to do that. That's kind of like the modern infrastructure for running websites from a security standpoint. You also probably want things like some protection against denial of service. That's not really security per se, but it can have a similar impact on your organization. If the script kiddies start running wild and just bombarding you with tons of pings, you want to have a way to handle that. You want your network to be secure and have some intrusion protection. You want to have encrypted communications be the default for everything. There's no reason that you want to be passing anything in the clear in this modern era. Let's encrypt all the things. And you want your systems managed via automation, and you want control of those systems and control of that automation to be centrally administered with role-based access and permission. So getting back to the human side of the equation. So that's kind of the recipe for success from a technology and infrastructure standpoint. And so now, just to take it down a level to get a little bit more specific, I'm going to walk through the full stack of running website infrastructure, and from the kind of state-of-the-art leaves a bit to be desired perspective that a lot of people are familiar with because it's probably what they're running on now. And then we'll talk about how it can work if you're sort of looking towards the future and you want to have a better security story. So starting with the public face of the website. Most websites are sadly still a pile of code sitting on a server somewhere. And that means that you have a single instance, it's got an IP address, and hopefully it can hold up to whatever load gets thrown at it. You could put a CDN in front of it maybe, but by default it's just going to be this one thing that sits there, and it's inherently highly vulnerable to denial of service. It also, in the standard way of the world, that front-facing domain name will map to the IP address that is actually the server, so people can just start port scanning your domain name to see if there's any services that are running. You could be turned into a spam email gateway. People could find an open old thing that was on by default in Ubuntu and back their way through it. It's sort of like, that's kind of the default, is that you're just out there and you're sort of exposed, and the zombie horde is milling about and maybe sniffing around to see if they can take you down. At the application level, the code is really just like a tarball that got unpacked on a server somewhere. And this gets important in a second because, as I've been talking, one of the themes that you'll be picking up is the unmaintained system is the vulnerable system. That goes for the website application as well. The CMS that is not maintained is vulnerable. And when the application is just a pile of code sitting on a server, it's a relatively large amount of work to maintain that because there's no tooling around the maintenance. There's no process for deploying it. It was set up last year by someone who was a contractor, and now someone else is trying to figure out even just what directory it's in and where it lives and how can you update it safely. And you need to be much more nimble and on it when it comes to keeping your CMS up to date. It shouldn't be a science experiment every time to do that. The database is probably not encrypted. This is available in most modern versions of the MySQL family and Postgres, but it's not used by default. In most cases, unfortunately, it's not configured by default. So the database channel is probably not encrypted, and it may be firewalled, or it may be available on the public internet. That's an open question. Underneath that, you have the Linux operating system. So to be honest, for a lot of systems out there, there is no administrator. They were set up at some point by a developer, and knock on wood, they're still safe. They're not being actively maintained. But even if you're in if you're in the best case scenario, you have a systems administrator, they're monitoring for CVEs, that's the mailing lists where the security announcements go out. They're running fire drills when necessary because a really big announcement went out, and otherwise they're just playing whack-a-mole with system updates as other things come along. You're probably also experiencing some pain because sometimes those system updates entail reboots or entail restarting critical services that might not come back exactly the way they were before, and so you have this that's where a lot of the enmity between developers and sysadmins actually starts from, because sysadmins are trying to keep things safe, but then they're kind of shuffling things around underneath the feet of developers, and stuff breaks, and then there's this finger-pointing game of whose fault it is. It's no fun. So on the network and physical security front, suppose you still actually have an on-site data center, or you operate your own stuff out of a closet. You have to be concerned with the physical security. You have to be concerned with the network security. That's not really a position anybody who doesn't run data centers as a core business competency should be in. The future is very much to outsource this, if not to virtualized machines in the cloud, at least to data center providers who can provide cages and climate control and redundant power and so forth. So if you're doing the super old school big iron ops, you might be getting some cost savings on the price of a machine, but you're giving up a lot because you're responsible for all these other things that could go wrong. And finally, you have to think about your developers, right? So in the normal run-of-the-mill set of things, there's no centralized management, there's no audit trail. A lot of times people are using plain old FTP, or somebody threw some SSH keys on some server somewhere, and it's kind of like an oral history or tribal knowledge as to how things are set up, and also how new developers get involved. So it's not great from a security standpoint, and it's typically also not great from a operational or velocity standpoint. And that's kind of the as is for a lot of folks that are out there today. So in the modern world, we think things should be different. Again, working away from the top down, the public face of every website should be highly available and horizontally scalable, and probably include a reverse proxy cache, so that if you have your moment of glory comes along, you can handle the traffic. If the denial of service attack comes in, you can deflect that traffic, and you don't have the front-facing, essentially the public-facing address of your website is not also an address that can be used to start scanning for compromises. You want to separate the edge from where your system actually runs. At the application layer, you need version control. I think most developers are on board with this, but practices still have to catch up. So things need to be versioned so that you can know when things were changed by whom. And you also need a scripted process, at a minimum, a highly documented and routinized process for doing deployments, so that they're done consistently the same way every time, and so that you can hand off responsibility for doing deployments to the application itself, to your website, from developer to developer. And ideally, you want a clear chain of custody for all the changes that go out, not just the changes in version control, but also when the deployments occurred, who did them, so on and so forth. At the database level, we should all be utilizing the encryption that's available when we're developers connecting to a remote database. There's no reason in the modern era to do that in the clear. Also, database connections between the application instance and the database, if they're separated, which they need to be if you're going to have a horizontally scalable application, they should be run only over the internal network. That's pretty much the way that you would set it up once you start to build out a cluster, but oftentimes people forget to do that, so don't forget to do that. At the core operating system, the Linux level, so everything here should be automated. There's not a case where you want to have sort of artisanal system administration still responsible for your systems, unless you have this incredible wealth of systems administrators who can keep you, fully covered with that kind of by hand bespoke process. You want to treat your servers like cattle, not like pets. You want them to have numbers, not names. You want to kill them regularly and feel no remorse. At the network and physical security level, probably most of you are already doing this, but you have a SOC 2 compliant infrastructure provider. They, do background checks on their employees. They have multiple locking mechanisms. Like, nobody's going to walk in and drop a thumb drive on something. Nobody's going to walk in, say hi to a receptionist, and then walk out with a box under their arm. And also, you want to make sure that all your traffic not only is running over an internal network, but it's encrypted. If the revelations about the NSA taught us anything, it's that we can't just trust network security with the sanctity of our communications. We also need to encrypt our communications where they're truly critical, because people can snoop on all sorts of things. Finally, for your developers, the people building the websites, you need to have centralized account management so people can come and go and you know that they've come or they've gone. You need to have an audit trail of what occurred, who added whom, and what they did. And you need to be using, in keeping with my last point, SSH for all developer connections, not just for some. And by default, I think a lot of people still default to some clear text communications around FTP. Just don't do it. SSH all the things, all the time. It's not that hard, and there's no reason to compromise on that in the modern era, just like there's no reason to compromise on version control. So just to talk a little bit more about systems automation, we are obviously huge believers in this. We could not run the scale of infrastructure that we run without it being entirely automated. It would be insane. There are great tools out there for doing this. Whole startups just devoted to the process of automating your systems. We're big users of Chef, so we think they're quite good, but they're by no means the only game in town. Ansible is another one that's pretty popular with developers. Puppet is another one that is another, if they've grown up, these are big companies now. They're successful startups, and they will happily provide you with open source tools as well as potentially commercial support to help you automate all of your systems. So the time for people who manage systems to take that leap is now. It's really, we're getting to the point where the only way that we can combat the zombie horde, right? The zombie horde is automation used for evil. It's scripts that exploit systems, exploiting systems, and turning those systems into things that run scripts to exploit systems. It's this exponential feedback loop of software that's used to do bad in the world. And the only way that we can actually combat that at scale is with software that's designed to do good in the same way. So if we can be vigilant and automate our systems administration, we can actually create an environment online that is capable of beating back the zombie horde, and that starts with all of us. So I encourage everyone to get on board with this as soon as possible if you're still managing your own infrastructure. When it comes to the actual website itself, beyond just the infrastructure component, it really breaks down into three things that you want to be concerned with. Your custom code, that's like at a minimum the design of your website, the specific things that make it yours. Any contributed plugins or modules that you're using, because most open source CMS implementations aren't just the core, they include a bunch of contribs with them. And then of course the core CMS itself. So the questions you should ask yourself is, when it comes to custom code, do you know that you're following the best practices? Do you know who made the changes and what they changed? Do you have a process whereby people at least get a +1 from someone else before a change gets accepted and released? Those are the table stakes. And if you do those things, you're actually probably going to protect yourself from 90% or more of the most common errors. Like you'll have an audit trail and you'll have a second set of eyes on things, so that a really obvious typo, like again, human error from the developer standpoint, a lot of security breaches start out as transposed characters, right? I just typed something and it looked right to my eye because my brain can work that out visually, and I didn't detect that I used AE in one place and EA in the other, and now there's a vulnerability. So having a process whereby you just have people work together and view that stuff, maybe some automated scanning to detect like linting and other things like that for code style, those are all like important ways of staying secure, because something that's messy is inherently difficult to secure versus something that's orderly is much more easy to audit. From the open source contributed plugins and module space, you need to know how to trust what you're using. There's just like a lot of code out there, and a lot of developers have open sourced their code just by saying, hey, I made this, I'm going to throw it over the wall to see if anybody else has use for it, but I'm not like really signing up to actively maintain it or to keep it up to date. And there's nothing wrong with developers doing that. You, as a potential user of that code, need to be aware of what you're getting into. Are you installing something that has an active team behind it that's responsive to bug reports, or are you essentially taking on the maintenance of something by installing it on your system? And with whether you use WordPress or Drupal, you can just dig in on those plugin pages, those module pages, and see whether things are being actively maintained or not. You should definitely be aware of the status of the maintenance, and then you should have a plan in place for managing updates. If a plugin is being actively maintained upstream from you, have a plan in place for keeping up to date with those updates that come from them, because again, unmaintained software is likely to be insecure software. And that's really the story for the core CMS. It's really about how are you managing updates, how quickly can you make an update. Last fall, we had a critical security bug in Drupal core that was discovered by some researchers, and a patch came out. And what we observed on our platform, we protected everybody on the platform. That's one of the nice things that we can do, is put in place platform-wide protections for things. But we didn't just block the exploits, we actually logged them. We were able to contribute back some analysis of what the exploits were, and that helped people deal with it. But the really interesting and kind of scary thing was, within 7 hours of the bug being announced and the patch being made available to fix the bug, we started to see attempted exploits from sketchy Eastern European IP addresses that were just working their way through alphabetical list of domain names, trying to use this vulnerability to place a backdoor onto a site. And that's kind of what you get. That wasn't the zombie horde. That was probably somebody who's like a criminal and does this professionally. But they've got a list of sites somewhere that they think might be running this software, and whenever a vulnerability comes out, they'll put something together. It only takes them apparently about 8 hours to put it together to run the automated exploit. And so you need to be up to date. If you don't believe that you can patch your core software within 24 hours, if you think, oh, it'll take me a week or a month to do that, you're running a lot of risk. You really need to think about how you're maintaining stuff to keep it more up to date and to limit the damage that can occur. So to sum up, the main website vulnerabilities are really about people, which is chaotic systems and human error. So try to tame the chaos if you can, and create layers of access so that the damage of human error is reduced, and if there maybe is oversight so that human error can be caught before it causes too much damage. That's really what it's all about. And on the technology side, you have your hosting infrastructure and your website technology, and the one takeaway, if you have one takeaway from this presentation, it's really about turning the process of maintaining your technology into a technology itself. It should be automated. It should not be a manual science giants project to do updates and to maintain these systems. The pace at which you need to make updates is too high now for the by hand process, the artisanal process, whether that's system administration or updating the website itself. The kind of manual, labor-intensive process for doing this simply doesn't scale. So think about how to turn that into software itself. So software is eating the world, software is eating software management as well, and that's as it should be. Just to talk a little about us, we're giving this not entirely out of the goodness of our hearts, because we do a lot of this for people. People trust us to manage their website infrastructure, and we do a great job of it. So we provide isolated and secure web infrastructure via containers. We provide role-based access and permissions for the developers of those websites. We give you administrative oversight into your teams, and a couple of new things that we announced earlier this month. We have a new integration of SAML, which is an industry-wide standard for doing federated login. So people who have central auth systems, that central auth system, if it's relatively modern, probably speaks SAML. You can connect that to your Pantheon dashboard and actually log in through whatever your company login system is. If you don't have a company login system, but you think you might be interested in one, there are really cool startup companies that'll do that in the cloud for you. Two that we've talked to and we know we can integrate with are Okta and OneLogin. And basically, they have nice packages for starters. Like you get 3 apps for free. So you could have Google Apps, your accounting system like Harvest, and Pantheon all working through one login. You could put 2-factor authentication on that login and kind of have your internal IT story around managing cloud services be like leveled up within a couple of days of putting these pieces together at very, very minimal cost. And we also offer secure runtime access. That's the other new feature that we've released. It's been around for some of our customers for a while, but now it's a first-class feature. And basically what that does is it provides a heightened security mode for website development, whereby all access to any resource on the Pantheon platform needs to be done through an SSH tunnel. That's not the default, because that can actually get in the way of a lot of developers, but we can enable it so that you are forced to do it that way. And what that does is it prevents any kind of eavesdropping. So like if you're doing development in the cafe, the sketchy looking dude over in the corner with the black hat can't be snooping on your traffic. Then likewise, because the creation of an SSH tunnel is itself an authentication check, if you have a subcontractor who's working on your project and they leave the project, they would no longer be able to make that SSH tunnel. Even if they had like a bunch of passwords written down on a notepad, they wouldn't be able to exploit them because the avenue by which they could connect would be blocked off. So that's a nice thing for security conscious organizations or organizations that have employee turnover as an issue. And we're happy to talk more about that. You can just get in touch with us through the normal channels. To sum up, you should be managing roles and access with practices like a secure sign-on and 2-factor authentication. 2-factor auth is the modern way. Get on board, do it like that, and you won't regret it. And running your website in a cloud where you have some kind of robust security feature and protection. So whether that's internally because you're embracing systems automation and really nailing that, or you work with a provider that does that for you. Don't run your website in your data center. Don't run your website on the same infrastructure that runs a critical core business system. And lastly, just stay on top of updates, because all of the technologies that we run, all these open source technologies, have great security stories as long as you keep them up to date. And that's really the critical thing. So if staying on top of updates is just the name of the game for security. That's how 99.9% of all breaches start, is with something that's out of date. And you can register for Pantheon for free, obviously. If you've never used our service before, just sign up, check it out. It's different than what you're used to, but we think it's pretty awesome. And there's no risk, and it takes about 10 minutes to give it a good trial. And at this point, I'm happy to take questions.
Righty, Josh. Our first question is, I'm a freelance Drupal developer who has developed many sites over the past 8+ years. With each year that goes by, the list of websites I own grows. What recommendations do you have for agencies or freelancers to keep lots of client sites up to date security-wise, especially when there are constant updates released to Drupal modules and Drupal core? It's a lot to manage, and smaller clients often don't want to pay for monthly updates for the rest of their website's life.
So this is a tricky question. There's kind of I think 2 questions in this question. The first one is sort of maybe a technical question about how do you manage updates for lots of sites, and the answer is you have to have the process by which you make these updates streamlined, scripted, and automated. When you're building sites for clients, it's a challenge because you want to be able to test the update before you deploy it. most clients aren't going to be super happy with a secure website that's also totally broken for customers. They would expect that you can get a test on that before it rolls out. So so that's something you want to think about having routinized and automated and have tooling in place for that. And that's sort of, as a professional, something you can invest in building for yourself. It's something that we do, obviously, but you don't need to use us to have a good answer there. The second question is harder, though, because if people don't want to pay for this stuff, that's a tough situation to be in, because they're essentially expecting you to do work for free. And I think this is part of how we set expectations with customers and as ambassadors of open source. Oftentimes people, business people, they see, oh, open source, it's no license fee, it's free, and it's gratis in the sense that you don't, that's the technical term that they use, we use the Latinate word. It's gratis because you don't have to pay up front for it, but it's actually not free, because the hidden cost of open source is that it takes time to use, and it takes time to keep up to date. And I think that we're moving more and more towards a world where not just for security update reasons, but for all sorts of other reasons, websites are not something where you just launch it and forget it, right? It's not that you do a design and you put it online and it just certainly there's brochureware stuff that just goes out and it'll be good for, from a visual standpoint for a year. But most customers that are interested in doing meaningful things on the web, they want an iterative process for working on their website. And so I think as professionals who build websites for clients, that's sort of the expectation we want to be setting, that there is a constant need to keep these things up to date, both for security, but also so that you can be doing the best thing for your business. And that, as a result, you should have some kind of business agreement in place so that the work that you're going to do to meet that need is going to be compensated. And the reality is you may have set some expectations with some early clients that they just get all this stuff for free, and that might be really hard to change for them. You might have to transition them so that somebody else handles that for them, or have a conversation with them about how their expectations aren't sustainable because they're kind of expecting you to work for free. But definitely anybody who's not building that conversation into their sort of client pitch and their general proposal should think about doing so now. And finally, again, for anybody who's doing agency work from a selfish standpoint, it's to your interest to build a stream of recurring revenue, to have long-term relationships that are steady and that are easy and that bring in work every month, whether or not you can land a new project or not. That's just going to make it much easier to grow and sustain your agency over time.
Great. Next question. I get clients that are weary of WordPress because of the latest security issues. Should they be worried?
So WordPress gets unfairly, I think, gets a bad rap. And part of the reason is that we're getting our noon siren here in San Francisco. It's the earthquake drill. Part of the reason that WordPress gets the bad rap is that, to my point earlier, that unmaintained software is insecure software. When you think about all of the infrastructure that's been set up out there, little one-off servers that are have an old, outdated version of Ubuntu on them that some contractor set up like 2 years ago, and it's still running, so keep it going because we need that thing, but we can't afford to keep it up to date, or nobody's really looked at it, or nobody even actually knows where it is. WordPress, by being so easy to set up, install, and use, is the same sort of thing for CMS. There are just so many random one-off WordPress installs out there in the wild that they're not being maintained, and unmaintained software is insecure software. I internally have seen numbers from WordCamps where they know that something like 35% of all WordPress installations are still on the 3.x era of WordPress, which means they're several major updates out of date, and that's a big challenge for them as a community, because if nobody there's nothing they can do about it. A pile of code gets put on a server somewhere and then it's left alone, and what do you know, a couple years later there's problems with it. Likewise, in WordPress, there's a lot of plugins that aren't actively maintained either by their upstreams, so you can have even a secure WordPress core will, if you've installed some kind of unmaintained plugin, if there's 50,000 installs of that plugin that aren't maintained and someone figures out a way to exploit them, that's going to get thrown into the zombie horde machine, and suddenly all websites are being scanned for this unmaintained and exploitable plugin. And so WordPress, I think, gets a bad rap just because it's out there so much, and so much of it is unmaintained. if you have a WordPress website and it's built by a professional and it's maintained in a professional manner, you really shouldn't have any security concerns that you wouldn't have for any website in general.
Righty, next question. You suggested that the website and email should not be hosted on the same server. Can you explain why?
Yeah, just to go into a little bit more detail on that scenario. This is something, I have intimate knowledge of more than one exploit that occurred this way. And really what it comes down to is usually the way that systems are architected when there's like a server or a production server out there is you've got like your website running under Apache and it's in like /var/www, and you have your mail and that's running via postfix or something, and that's in like /var/spool/mail. And what that means is all of the email is being directed at the same server that all of the web traffic is being directed at, and oftentimes that mail spool is readable by the website, the system daemon that runs the website. And if there is a exploit to the website that allows an attacker to trick the website into trying to read other files outside of its normal area, one of the first things they'll try is just read me whatever's in var/spool mail, because it's a rich target, right? That's a default place that stuff gets set up, and if you can read it out, there might be some juicy bits in that email. So that's a good reason to not put those things on the same server. I would also just say in the modern era, there used to be in the olden days of the internet, postmaster at any domain name was like a real email address that was checked by a person, and if you had problems with email coming from some domain, you could send email to that domain's postmaster, and there would be some system administrator there who would be checking that inbox dutifully, at least on a weekly basis, and they would get back to you. And it was kind of this like small community. It was like you go to your neighbor and say, hey, there's a racket coming from your place, can we talk about this? In the modern era, if you're running your like one-off instances of mail environments, you're asking for trouble, because there are so many exploits that came up and have been evolved over the past decade around exploiting unprotected mail gateways for spam and other reasons. I really would say don't run your mail at all. Like, you should be taking mail to a third-party provider like Gmail or someone else. If you're concerned with the security of going with a big company, there are like very privacy-centric companies that specialize in doing this. Like mail, and the beauty is that we designed a DNS to work this way. You have a separate record, an MX record for your email. It's different from your main domain pointer. So you should be pointing your email at something that's much more hardened and secure and separated from your web infrastructure. That's just a modern best practice.
Ready. Next question. How do you handle keeping PHP up to date? We have a Drupal site.
So PHP updates can sometimes create issues, because when you go to the major versions, functions that are written into the CMS become deprecated. That starts generating a lot of warnings and errors. This is a problem famously for Drupal with 5.2 and 5.3. It's also a problem for WordPress, given their commitments to backwards compatibility. The short answer is if you keep your CMS up to date, the problems are minimized, because the problems you have are where you have older versions of the CMS that rely on these older functions that are no longer present or are deprecated in the newer versions of PHP. The other answer is that you can oftentimes patch these things yourself if it's super critical. I would say that the main reason you want to stay up to date with PHP is actually not necessarily security. It has more to do with performance. In terms of the things that are coming out now, which are sort of PHP security vulnerabilities, they all rely on you being able to already exploit the system in some way. It's not just like, oh, there's a vulnerability in PHP where any website, if you just point the right URL at it, gives you access to something. It's more like you have to be able to pass in a specially constructed array that needs to be deserialized or reserialized in a way that allows you to inject commands or do something like that. It's pretty hard from a website perspective to have PHP itself be the core vulnerability. It can be a contributing factor, but I will say that it's not optional to run super outdated versions of PHP, because you're dragging your developers back and you're making your website visitors wait for an antiquated engine to take a longer time to process responses.
Righty, next question. Does Pantheon recommend any particular solution to address the user/login/admin pages pinging by bots poking around for insecurity flaws?
Yeah, so this is kind of the similar question around admin pages, as it's similar kind of to comment spam, actually. Like everybody who runs a website, you're familiar with comment spam, right? And that's because robots have exploited your comment system for spam. Those robots are probably also exploiting your user login pages, or they're trying to. And so for user login, two-factor auth is really the way to go. You can add a CAPTCHA there as well, which is not a bad thing to do. That might be an easier step to take today. But you should really be thinking about two-factor auth for your CMS itself, and if possible, tying the CMS login itself to a centralized auth system that has two-factor on it.
Righty, next question. Two-factor authentication.
Oh.
Is there, or will there soon be, a way to require this for login to dashboard.pantheon.io?
Yeah, that is sort of the included in the new feature that we talked about with SAML login. It's not two-factor provided by us. It's more, because the way that we look at it is people already have, there's like, the proliferation of 1 million places that you need a second factor to is not long-term that much more sustainable than 1 million different passwords. And so what we're looking to do is integrate with existing systems. In the future, also something like Google authentication, where you use your Google account, and that's the master account that you use to log into things. That account has two-factor. Our SAML integration allows you to use your own central authentication system, most of which you should be having two-factor there. That's the pathway that we propose now.
Ready. Could I set up an automatic update for core and contrib Drupal modules like WordPress, or is it better to do it manually?
So this question kind of refers to, there's a capability in WordPress where you can turn on auto core updates, which if you're doing no real customization is probably pretty safe, but if you're doing any amount of customization that is significant, could be unsafe. It's a double-edged sword. There is actually, I can't remember the name of it off the top of my head, but there is a service out there that will update all of your Drupal modules for you, and it costs like $50 a month or something. And it's sort of like people will pay $50 a month to potentially break their site without warning. So there's a tension between, when we talk about building websites, between the need to update things frequently to keep them secure, but also keep the website up and running and bug-free. So I think if you have very, very little customization on your website, an automatic update is potentially fruitful. What I think is more likely to yield value to more people is a process that makes updates really easy and makes testing the updates really easy. And that's kind of what we're focused on working on our platform, is figuring out a way for people who manage hundreds of websites to really quickly see, the update is easy to do, and I can verify that the update doesn't break these sites, and now I can make the update live, versus just blindly making the update live automatically.
Right, we have a follow-up question to that, or related question. Is there an option on Pantheon to turn on or off auto-updating Drupal or WordPress installs? If so, can it update modules/plugins and themes, or does it just update core stuff?
So right now what Pantheon does is it provides the core updates as a one-click operation or a one command line operation if you use our command line tool set. So we don't actually auto-update anything for you, and it's because right now we've made the cost-benefit judgment that it's better to keep the websites running than to potentially take them down with an automatic core update. However, it is pretty straightforward to set up something on your own that automates some of Pantheon. You can automate on top of Pantheon using your own Jenkins instance or Circle or Travis or what have you to say, there's an update available, let's pull it in and let's deploy it. And that would be your choice as to whether that update should be just the core or everything else. And that's kind of, we're looking to build more tooling around that to help people with those sorts of things, and maybe provide some reasonable defaults for being able to pull in updates and test them. But right now we definitely have customers that have done that, with their own skill. Like one of the things we see people doing is we take away and take care of all of the kind of traditional sysadmin tasks. So you have some people with DevOps savvy, and suddenly they can apply that savvy to a new set of tasks, like automating the updates across all the websites and making sure they don't break anything. I think that's a winning trade-off to make. We're going to look to do more of that, provide more sane defaults and useful tools out of the box right now, or in the future. But right now, it's really just the one-click core update.
Alrighty, we have time for one more question. We're going to end on this one. So if we are Pantheon users already, what is covered for security and what do we need to think about?
So users of Pantheon have their core website infrastructure security handled. We have an amazingly good story when it comes to this. The internet-wide fire drills like Heartbleed and so forth, we're way, way ahead of the pack in terms of having those things handled. We treat our servers like cattle, not like pets. We maintain the core system updates. We maintain the kernel updates. We handle everything from the application environment on down, and we do a really good job of it. So you don't have to worry about any of those things. The zombie horde sort of stuff really is off the table. We've created a nice perimeter. What you do have to think about, though, is your website. We make those one-click updates one-clickable, but if nobody's clicking, then they're not getting updated. And that's something that we want to do more to help people with, to even make it easier and more automated or provide alerts. But really, on Pantheon, if you're a Pantheon user, the website is still your responsibility. We make that you own the code, so to speak. And so you should be thinking about the process by which you're making those core updates. You should probably also just still be thinking in terms of broader, like what should I do about security? What am I integrating with? How am I handling my email? All those other questions are still questions that should be on the table for organizations. But everything from the stack behind the websites on down, Pantheon takes care of for you. We also take care of the administrative tooling around user access, developer access. So if you're worried about subcontractors, you're worried about disgruntled employees, with Pantheon in the mix, that's much less of a concern because there is central administration of users and you do have an audit trail.
Alrighty, Josh, thank you so much for a great presentation, and thank you all for watching. If you have any questions or feedback, please visit our website where you'll find a Contact Us page and we'll put you in touch with the best member of our team. Have a great day.